Hello everyone, and in today's video we are going to understand the concept of projectile motion. I'm sure that you must have heard about projectile motion and you must be thinking what is happening with this resolution of vector, the y-axis, x-axis. I'm sure that there must be some confusions, there might be some confusions within you that you need to clarify. So let me tell you, projectile motion is a beautiful example of resolution of vector in action. Yes, it is an example of resolution of vector where we are resolving the velocity component into two parts and we are giving them a separate treatment according to the action which is happening in each of the parts. If you have to understand what I told you right now, you have to see the derivation for it. So let us get into the derivation for projectile motion. So as you see, students, it is about the projectile motion. So first let us understand what is this projectile motion. If I say a projectile motion, it is, we are going to understand the motion which is an oblique projectile. Okay, so there are two types of projectile. One is horizontal projectile and the other one is oblique, where I am going to discuss only oblique. Let's imagine that we are sending a missile. Okay, so how do we send a missile? Right, we make an angle with the surface. Okay, we make an angle with the ground and launch the missile. That is one example of a projectile motion. Okay, so I'm going to do the same thing here. I'm making an angle and launching some object. Okay, so I'm launching some object here which I'll represent it with blue color, and this is my launch of an object, and you see here this is my initial velocity vector which I represented with u. I represent it with u. This is my initial velocity vector u. And this initial velocity vector is making an angle theta with my ground. So basically it is like launching a rocket with the angle theta with respect to ground. Okay, so I have launched my rocket. Now the first thing that I'm going to do here is resolve this initial vector. I'm going to resolve this initial velocity vector into two components, whereas you understand that this component that you're seeing here is going to be your u cos theta, and this component which is going to be exactly vertical to the ground. Vertical to the ground means making 90 degree with the ground is going to be a u sin theta. So I have resolved my initial speeds in two component. Okay, now I have two initial speeds in each direction. Horizontal component is u cos theta and my vertical component is u sin theta, because I have resolved my original vector here. I have resolved my original vector. Now generally you know that as soon as the journey begins, it goes like this. The journey goes like this and finishes. I will show you to a red color line. So this is how the journey looks like. It goes, makes a semicircular path, attains a topmost height, then comes back and falls under gravity. So you see here it is only the gravity which is controlling the motion. See, as soon as I launch the missile or whatever, it reaches a maximum height, then it comes back and falls back to ground. And what is the reason why it falls back to ground? The reason behind falling back to the ground is gravity only. Okay, so now I am going to calculate some things here. First, let me calculate the maximum height attained. Okay, I want to calculate my maximum height attained. Now look here how I am going to use my vector concept here to get my answer. Let me begin with maximum height. So projectile is going up, reaching a maximum height, and from that maximum height comes down. So you see that my maximum height is somewhere at the center point here, is going to be my maximum height, which I am going to call as HM. I want to calculate my maximum height. Now remember the equations of motion. Let me write those equations of motion for you here, because they are going to help me here a lot. Okay, so I have V is equal to U plus AT, S is equal to UT plus half AT square. Then I have V square is equal to U square 2AS. I'm sure that you know these three equations. Now I am going to use these equations to attain my answer using the appropriate component. First one, I want to find my maximum height. So maximum height is measured vertically. Maximum height is measured vertically. So obviously, which component am I going to use here? I am going to use the vertical component of initial velocity, that is u sine theta. So I have my initial velocity, u sine theta. Okay, my initial velocity is u sine theta. I'll just write initial. My initial v is u sine theta, which I already know. You know, right? I require initial velocities in this formula. Then the height which I need is hm. So my displacement is hm. My initial velocity is u sine theta. My displacement is hm. My acceleration here is minus g. Why minus g? Because it is going against gravity. So my acceleration is minus g. Isn't it? It's going against gravity, so that's why my acceleration is minus g here. And do you know what's my final velocity in this case? My final velocity, you look here, as soon as the object goes on top, it momentarily stops here. After stopping, it starts to come back down. So I need to know where it exactly stopped. So basically, it stopped exactly at the point hm. It, as soon as it traveled on top at the point hm, it stopped, and that time the velocity was 0. Final velocity was 0. So I have initial velocity, I have s, I have acceleration, I have final velocity. I need to find s, of course, hm. So I will be using my third equation to get me the answer. So I substitute all my values. 0 is equal to u square sine square theta, obviously, plus 2as, but here it's going to be plus minus g, 2 into minus g, because my acceleration is minus g, into hm. So obviously it's going to be, when I send this negative side here, u square sine square theta divided by minus 2g, right, is equal to h max. So minus minus will get cancelled. My h max, the maximum height attained by my projectile, is going to be u square sine square theta divided by 2g. I got my first formula. Simple and straightforward. Simple and straightforward. My formula for the maximum height is u square sine square theta by 2g. So I did not do anything new. I just used the equations of motion and I did the resolving of vector. Now let me find out the time of flight. Okay, let me find out the time of flight. We call it as time of flight. Time of flight means how long it has been in air. How long it has been in air. That's my time of flight. So look here, it started its journey at this point. Students, look here clearly. It started its journey at this point. It went on top and it finished its journey here. So how long has it been in air? That's called time of flight. Now for that, I require to use any one of the equation of motion. Now let me see again. I have initial velocity, I have the maximum height which is already found, I have acceleration, I have final velocity, wherein I require time now. I require time. Now there is a possibility, so I'll call TF. But you look here, I can actually find the time taken to reach this point. You know how? I can use these values. I can use my vertical components. So now the time I have to find out the time taken to reach the maximum height. That's all. What I want to find out is the time taken to reach maximum height, which is going to be t. Let's imagine the time taken to reach maximum height is small t. So that means it travels for another small t time, right? See, it travels for time small t and reaches the maximum height. Okay. Then another time small t it travels to reach back. So your total time of flight is 2t. Isn't it? Makes sense? Your total time of flight is 2t. Half to reach maximum point, half to reach come back to ground. So now let me find my small t first with these given values. So time of half flight, that is small t, I can use the first equation to get the answer. Okay, so v is equal to u plus at is what I am going to use. Now I'll substitute all the values. 0, u is u sine theta. I'm using my vertical component because I want to see the time taken to reach on topmost. My velocity is 0 there, acceleration is minus g, and time is small t, which I need to find out, which is going to be obviously t is equal to u sine theta by g. So my TF is of course going to be equal to 2u sine theta by g. This is called my time of flight. Understood? I got my two things which are required for me. I got my maximum height attained by the projectile using the vertical component. I got my time of flight also using the vertical component. Yeah, here also I use the vertical component. Now I want to find the range of projectile. Now this distance from A to B, this distance between A and B, that means how much horizontal range it covered. That's called range of projectile. I need to calculate range of projectile. Okay, now range of projectile is the horizontal distance my projectile traveled throughout its journey. I found my maximum distance, so maximum height, the maximum height it could reach. Now I want to find out the maximum range that it traveled horizontally. Understood? I have to find out maximum range it traveled horizontally. Now what is my requirement? I am dealing with the horizontal component, so my initial velocity now is going to be my horizontal component of the velocity, which is u cos theta. So my initial v, now the initial velocity in this case changes. My initial velocity is going to be u cos theta. Now why cos theta? Because now I am doing calculation for horizontal range, horizontal distance. So for horizontal distance I require horizontal velocity, which is my u cos theta. For vertical distance I require my vertical velocity, which is my u sine theta, which I have already done here, isn't it? Now I go back. Initial v is u cos theta. Now I'm not using my final velocity here, rather I'm going to go with another formula, that is s is equal to ut plus half at square. Why? Because I already know my time of flight here, isn't it? My time of flight is a total time traveled, which is going to be 2u sine theta divided by g. Okay, so I have my initial velocity, I have my total time. Now, do you know that your acceleration is 0 in a horizontal case? In my vertical, there was an acceleration which was gravity. So my acceleration was minus g. But in a horizontal component of a projectile, the acceleration is 0. That means my horizontal component is traveling with a uniform velocity. There is acceleration only in the vertical component, and that was my minus g. So in my horizontal component the acceleration is 0. So I just apply this formula. So my distance is the range which I am trying to find, which is r. So obviously my r is going to be equal to, so a becomes 0, so this part disappears. So if I use, see, let me show you, I am using this formula, r is equal to ut plus half at square. So a is 0, so this whole thing goes to 0. So r is equal to u cos theta into time of flight, which is 2u sin theta divided by g. So obviously now a little bit of mathematics coming into play. 2 u square, okay, now listen here, u into u becomes u square, 2 u square, and I have all, I can write u square into 2 sin theta into cos theta divided by g. Does this equation look very much familiar to you? Look here, look at this portion, 2 sin theta cos theta. Now trigonometry comes to help me. I know that sin 2 theta is going to be equal to 2 sin theta into cos theta, isn't it? My trigonometry says that sin 2 theta is 2 sin theta into cos theta. So I just substitute 2 sin theta here. So my r is going to be equal to u square sin 2 theta by g. This is the value of my horizontal range. This is the value of my horizontal range. Okay, so my horizontal range also depends on the angle which I am making. Time of flight also depends on the angle which I am making. Maximum height also depends on the angle. So for a oblique projectile, the angle plays a very important role in all the distances. So this is my horizontal range. Now what can be my maximum range? I need to calculate what's my maximum range. So of course your maximum range is nothing but u square by g. How? Because your sin 2 theta has to be equal to 1. That is when you will get your maximum range, which is going to be u square by g. Now in under what conditions sin 2 theta can be 1? That's when theta is 45 degree. Sin 90 is 1, so 2 theta is 90, so theta is 45. So it says that this brings to a conclusion that when I am throwing a projectile making 45 degree, it attains its maximum range. If I throw it above 45 or below 45, it is not going to reach the maximum range, obviously. Understood? So my idea is, if I want to attain the maximum range in the projectile, I need to throw it exactly at 45. Above 45, below 45 is not going to give you maximum range. So this is the theory of projectile, and I have showed you how beautifully you can calculate maximum height, time of flight, and range of a projectile. I hope you understood this particular class. I will end this video with this discussion. Of course, I would like you to take the poll and let me know what is the video that I want to make for the next 11th course. Okay, so there are different concepts which I have given in the poll. Please do select, and whichever concept many people select, I'm going to make the video for next 11th class video for that particular concept. So I want you all to participate here and give your valuable feedback, so that I'm here to help you to understand physics better, make physics easy for you all. So with that, I'm ending my today's video. I'll come up with the next 11th video probably after the next cycle of 10th, 12th, 9th, and then 11th again, because I'm trying my best to give or cater all these 4 grades, 9th, 10th, 11th, and 12th. So that's why if I'm trying to release 2 classes per week, that means to get 11th video it takes the next 2 more weeks to come. So please do have patience with me. I'm trying my best to make as much as video as possible to you, and I'll try. That is the reason why I give you the poll, so that I know what is the requirement of the students or what is the requirement of my viewers. So I'll sign off for now. We will see in the next session. Goodbye students. Adios.